Hello and welcome everyone. So I'll be explaining you a very good problem called it's from the recent Div3 round 693 problem E.correct placements. So in this problem I've got n friends, each of them have their own height and width. I can relate them to as a rectangle, and the main part is that I will have to take a group photo, and each and every friend should be visible, and for that one friend could come in front of some other friend, but there's a condition to fulfill there. What? Both friends are standing or both lying. Okay, this condition. Okay, I've got two conditions where all of them might be visible, and I have to structure them like this. So how is that? Whether both friends are standing or both are lying, this is one case. Okay, this is one case when hj is less than of hi. Okay, between two friends I'm comparing. And also another case is that one of the friends is standing and the other one is lying. So I'll explain you with a bit of a visible part. Let's say one friend is this and the other friend is this. So this is one valid shot, and also I could say this is another valid shot, and this is actually from the first conditions. Okay, and let's take one from the second condition. Okay, not this one, let's take this. Okay. From the second condition, sorry. So this is also another valid shot. Now we have to determine for each and every friend, and for each and every friend. Okay, so we have to determine for each I, or for each and every friend we have to find any j. It doesn't matter which j, and it such that the jth friend can be located in front of the ith friend. Okay, and also note one thing to notice here, that we do not need to find the arrangement for all people for a group, which means I can use one j multiple times. The answer can be, which means that one answer can be from one answer can repeat for one index. Okay, for let's say for index 1 I've got answer 3. It might also happen that for index 3 I've got the answer, for index 4 I've got the answer index 3. So it does not matter because each of the j is independent. Okay, so I'll have to just compute all possible pairs for each of the index. I have to find one of the j which can be located in front of him, and it will be independently. Okay, so which means independently means one answer can be again repeat. So we'll be given test cases n, and similarly the inputs, the heights and widths, and we have to finally find the answer. So to generalize this problem, what I actually did was, initially I will be taking input values of the height and width, right? What I'm gonna do is, when I take those pairs, okay, height and width, I will sort them meaning by here only smaller values will be available, and here only larger values will be available. So for each and every pair individually, I'm going to sort each and every pair that I'm inputting by, I'll show you how I did that by this. Look, I'm taking LL and RR, the height and the width, and I'm just checking whether LL is greater than RR. If it is greater than RR, then I'm just swapping it, which means I am making sure that this value always seems smaller than or equal to this value. Okay, So I'm always tracking this as maximum one and always this as a smaller one. Then what I did was I did a pair sort, a structural pair sort according to this pair. Let's say I've got one pair here and here another H3 W3 H4 W4, right? And what I did was I actually sorted the vector or the structural vector according to this. Okay. Now, how is that going to help us? By sorting this portion, what actually, if you analyze it, what do we actually need to find out? We actually need to find out for each and every index. Let's say the middle index is here. I'll draw it visually more. Let's say H1 W1, H2 W2, H3 W3, H4 and W4, right? So what I did was I actually sorted from this first value pair from pair's first value. According to the first value of the pair, I just sorted that. Okay, I just structure sorted, and then as I already know, okay, these values are already sorted, right? And according to this, these are sorted on their own way. Here, like I just did just a simple pair sort according to the first element. Okay, relating to the first element, I'm just sorting that. And now what do we have to do then? We actually need to find, let's say for this ID, okay, we actually need to find some pair from here which are less than H3, guaranteed, which pair will give less than H3 and also less than W3, right? So I need to find such pair from these sort of indexes, because I'm actually for one value I'm guaranteeing this here. There might be a possibility that I'm getting a lesser value here, but I'm not making sure for both of the values. That's exactly what I need. Two pointer. I need two pointer to find out this value too, which means I need two pointer to find out a proper pair which gives me these two values, which are respectively less than H3 and less than W3. Again, as I told you that I have sorted according to the first element, so I don't need to worry about this, because I will always get I can always track some value which is less than here. Okay, I need to worry about this one, right? Because these are not sorted. I have sorted according to this, not according to this. So to make sure that I get the best pair possible for each of the index, that's exactly why I need two pointer. Okay, so now how did I make sure that I'm gonna get the best let's say best answer for each and every index? We need a prefix calculation. So what actually I'm doing is I'm actually calculating from the first one. Actually, if you analyze it, I will never get answer from the first value, right? Because it is already the smallest. I won't get any smaller from this pair. So for that pair, answer always be -1. Minus 1 is actually for if you cannot find any answer, the output will be -1. So I know that this is the smallest pair ever, right? I can't find the smallest one from here because this value does not have any smaller. This is already the smallest. That's why it's always -1. So I'm gonna always start my loop from here, right? I'm gonna always start my loop from here, and I will check whether, unless, okay, I'll show you an explanation here. 3 4 5 4 3 3 might be better, or what? Okay, 3 4 5 4 3 3. Let's take this one example. 3 4 5 4 3 3. So 3 4 5 4 and 3 3. If I do a pair vector sort according to the first element, right? No, first of all, what I will do, I will just sort the pair itself. So the result will look like something like this: 5 4. Okay, it will be 4 5, right? I'll just do that. 3 3. And then I'm gonna sort this vector. If I sort it, it will look like 3 3, right? And then 3 4, and then 4 5, right? Now I've already told you I will start my loop from here because for this index I already know the answer. It's always -1 because it does not have any smaller one, and I have to check. But one thing to notice, I've told you that 2-pointer, right? One pointer will always be indicating what? The first index, right? One pointer will always be indicating the first index, and the other pointer will always be indicating this index. And I will find out until I reach this J. I'm going to find out the best pair yet I'm making. How am I making sure of this? I will only care about what? This index, right? So I will only try to make this value. I will only try to make minimum value of this by keep tracking like an if condition. If minimum is if this second value, let's say second value is less than or equal to minimum, then I'm tracking what? Minimum equal to that second value. Okay, why I'm doing this and how am I making sure of this? Because I know that I'm running my loop and checking the best yet until what? The J pointer. So it is always proven that until these okay, first one thing to notice here, I will also check whether these two values could be equal, right? I'm not gonna find out whether two values are equal or not. I will always find out which one is less than, right? I will always find out the less pair for every index that I can get. So this will also create a problem, so we have to deal about that too. So like if I do the operation here, I'll show you how I'm gonna do the operation for this. Okay, I know the answer always, right? -1. Now my pointer is this here. Now I'm actually comparing whether this J value is equal to J-1 or not, J-1's first value or not. If they are equal, then I don't have to do anything. I will just run out my J and I won't increase my I because I know that this value and this value are equal, which is indicating that I haven't got any kind of best result yet. That's why I'm improving my J so that I could make some non-equal values. When I traverse it and I find the best one, I'll show you with the code, you will understand more. Let's see. I'm taking the test case and I'm taking the minimum value here, and this is for the track. I'm initializing everything with -1 and initializing that I haven't got the best of anything of any index. And this is what I did was sorting each pair. After that, I inserted in a vector structure type, and this is for if n equal to 1. If n is equal to 1, it's always -1 because you can't get any smaller values than that. And then after that, I just sorted the value, sorted the vector. How did I sorted the vector? First, I'm giving priority of the first one. This L and R is representing the first and the second value, and this ID is gonna play a very big role here. Why? I'll show you. This ID is representing the pairs index itself, okay, inside the pairs actual index. Okay, this is going to help a lot. Now when I sort the array, now I will do what? I will start my loop from the second one, like j equal to 1 and I will be equal to 0. And I will also check what? I will check whether if VV of j of L is equal to VV of j minus 1, the immediate previous values, first one and the present first one. I'm checking that, I'm comparing that, because when they are not equal, which guarantees us, yes, I can get at least something. I can get, there's a possibility that I can get some smaller values than that, because I know that the first value is smaller than the because those two, because I've already sorted according to the first one, and whether if as I have sorted this vector, I will be perfectly sure that if they don't match, which means this previous value is definitely less, this previous first value is definitely less than the current one, and then I'm gonna try to make my the pair's second value, which means the R value, the best as possible, until I go to where? Until I come to the point where J lies. Okay, until I come to the point. Now then, exactly what I did here. Look, then I run out a while loop, and I'm checking whether my previous I is not equal to J or not. Okay, because if it becomes equal, which means I am on my current point. But until, so I will run out the loop until it becomes equal. So inside that, I'll try to make the best rightmost value, which means the pair's right value, as possible. How am I gonna do that? I am tracking out a minimum value here to find out the minimum, and when I check the best minimum, I will also keep track of the best minimum's actual ID. Remember what I said, actual ID, not the I. I'm tracking what? The actual ID, because this is going to play a big role. I have to generate for each pair's exact index, right? That's why this ID is helping us. So TID, I'm just keeping track of the real best results ID, which is going to help us after when the loop exits. So when the loop exits, I'm going to track, okay, the best minimum I've got till now, whether it is my current values less or not. If it's less, then I've got my best values, and I'm gonna track it in array. Remember what array did? Here array, I just tracked what? Initially I tracked -1, but now as I found out the best result, I'm just keeping track of the index, because what I need to find out ultimately was the best pair's index if I find out any best pair. Otherwise, it's going to be -1 because I cannot find it. So that's how I'm going to do it. Now, what happens here? Okay, if they get equal, if the current value is equal to the previous value, which means they have some similarities, they might have some common best result. That's exactly what I did. I'm not counting any kind of minimum result, because I know that this else part is actually referring, I'll show you what it's referring. That else part was referring to this sort of cases when it occurs, like 3 3, telling you 3 3 3 4, and like 4 5. That else part contains when I have this sort of situation. So when this sort of situations occurs, I don't have anything but to draw the latest minimum that I've got. I cannot draw anything other than that, right? Because if I draw something, I will never get any best result, because they are already equal, right? Already equal. So I will just have to keep pace with the minimum best that I've till got. So if they let's see, so that's exactly what I'm doing. I'm not running out some while loops here, because they're already equal. The previous value, the current value, and the previous values are already equal, which is not what I'm used to see. That's why the minimum will be the same. The the minimum that I'm going to track it out, whether it's smaller or greater than the rightmost one of the current one. That's exactly what I'm gonna do, and I'm always running. Look, I'm always running the J pointer, but not always running the ith pointer, because the ith pointer will only run when what? When I've got any difference. When I've got any difference, it means that I have a balance to, I have a chance that I can make the minimum out of it, because I've already sorted that. If it's equal, I'm not going to do that. I'll keep trying to make the best result with the minimum that I've got yet. And I'm tracking out J pointer each time. I'm just increasing that, and finally just returning the result. Also doing the same thing here. The real index, I'm gonna have to store it. The real index, okay? Here it comes. Also, always the real index. That's exactly what I'm doing. And finally just printing the answer. I hope you got the intuition here. So till next time, goodbye.